Okay, in this video, we're going to look at a vector which is joining 2 points in R2. Okay, and this would be the same as in R3. So consider the vector AB, which connects the points A and B, A1, A2, and B1, B2. So this is the vector I've drawn here. So far, we've looked at how to write vectors if they're starting at the origin. So let's say you have the vector starting at the origin and going to this point A. Right, so that's the vector OA. Then we know that we can write that using the coordinates A1, A2. And then similarly, there's this other vector starting at the origin, going to the point, going to the point B. So that'd be vector OB, which we can write using its endpoints, B1, B2. So when we write a vector using components, A1, A2, B1, B2, whatever the components are, you mean the vector starting at the origin, going to that endpoint. But what happens in this case of AB, where the vector doesn't start at the origin? How are you going to write that using its endpoints? So the way we're going to come up with this is look at this triangle here, OA, AB, OB, and come up with an addition statement. So notice if I added OA and AB, I would have the vector OB, just by using like the triangle property of addition. So OA plus AB is equal to the vector OB. Okay, and now remember we want to come up with how do you write this vector AB, so I'm just going to solve for AB. So subtract OA from both sides of the equation. So this would be minus OA. And then I know these in components. OB is the vector B1, B2, and OA is the vector A1. Oh, that's right, B1, B2 minus the vector A1, A2. So if I subtract these two vectors, I would subtract the x values. So it would be B1 minus A1 and B2 minus A2. So that's the vector AB. So that's the components of vector AB. So just going to do an example here to kind of illustrate how or why this is the case. So let's consider if, let's say A is the point, say minus 2, 3, and B is the point, let's go 2, 5. So let's draw that. So minus 2 be over there. So 1, so minus 2, 3. Point A is right around there. And point B, 2, 5, would be the point around here. So this vector here, we're looking for the coordinates of that. So AB, sort of by our definition up there, is the vector B, OB. So that would be 2, 5 minus 2, 3. Notice here when I write 2, 5, this is a vector, right? Vector minus a vector. You can't do, it's not the point 2, 5, it's the vector. minus the vector, because you can't subtract points, so we're subtracting vectors here. All right, so this is OB minus OA. So that's going to be equal to, I have to subtract x components, so 2 minus negative 2, and then 5 minus 3. So that's the vector 4, 2. So let's see, how is that the vector AB? So if I extend here, 4 is over here, and 2 is there. So when I write the vector 4, 2, what I mean is the vector starting at the origin and ending at the point 4, 2. So the vectors, I've drawn two sort of separate vectors, AB and then this vector over here, but these vectors are the same vectors because they meet our definition of equivalent vectors. They're the same magnitude, same length, and they're in the same direction. So the vector AB, you write it as this sort of equivalent vector, which is starting at the origin and ending at the point 4, 2. And that's how you do it for any vector which is between 2 points. You have to kind of write the equivalent vector, which would be starting at the origin and ending at whatever the point is, which you find by doing the vector B, or OB minus the vector OA.